Hello, everyone. Today, I'm really excited to welcome Dr. Andrew Ng, CEO of DeepLearning.ai and CEO of Landing AI, and also managing GP of AI Fund, and co-founder and chairman of Coursera. So, Dr. Andrew Ng, he needs no introductions, and he is one of the pioneers in machine learning in general. Today, I'm excited to talk to him about a specific topic in machine learning around how to bring machine learning from proof of concept to production. So with that, let's kick things off. Andrew, you're a pioneer in machine learning and making ML more mainstream. First of all, do you think ML is mainstream now?
It's great to be here, Swami. I think we're still on our way, but the adoption of AI and machine learning hasn't stopped yet. Over the last 20 years, with the digitization of a society, a lot of paper records, paper medical records, paper records over many industries got turned into digital records. And I think that laid the foundation and made many industries more AI ready. And over the last decade, we've seen AI first take off in consumer software internet companies, but now increasingly in other industries as well. And even though AI has created tremendous value, and a lot of people are talking about it, I think that the most exciting activities are still yet to come.
That's awesome. I think you're pointing out that there is so much, the industry is ripe for adoption of machine learning. And we see this today. I mean, in fact, in AWS, we have like more than 100,000 customers already using machine learning. But one of the things we actually constantly see is CEOs and even CTOs asking, saying, like, how do I get started with machine learning? So can you share some advice for CEOs and CTOs and the top leaders in a company on how to be successful with ML?
Yeah, so published online a document called the AI Transformation Playbook that I hope leaders and executives wanting organizations to go through the digitalization and AI transformation journey will find useful. AI Transformation Playbook. I think that the number one mistake that I see organizations make is taking too long to get started or taking too long to plan it out. I've had CIOs come and say things like, hey, Andrew, my data is a mess, my data is really siloed, so really needs to be cleaned up. Turns out everyone has messy data that is siloed and needs to be cleaned up. This is true for pretty much every company, almost every company. Yeah. But most organizations today have enough data to get started. And I find the companies are better off jumping in, getting your hands dirty, deliver a quick win, a smaller project, quick win, and use the learnings of that to grow to bigger and bigger projects over time. Also, in AI Transformation Playbook, we talk about how it's important to start with small pilot projects, deliver quick wins, and then also start to build a team, provide broad-based training to the organization broadly, including at the executive and the execution levels, and then also formulate a thoughtful strategy and maybe manage communications. One of the most interesting things I learned speaking with CEOs is, again, many CEOs said things like, hey, Andrew, let's formulate a strategy. When I have my strategy, I'll go to my board to get approval, and then we'll execute. And actually push back against explicit requests that CEOs wanted, because I felt that for a lot of companies, until you've done the first few projects, the strategies that companies come up with can be a bit theoretical or academic. Like read in the newspaper that data is important. So strategy is collect a lot of data. And I find that until company has gotten its hands dirty, it's harder to formulate that thoughtful strategy. But sorry, I think you have participated in this AI journey for a lot of companies. I'm actually curious what you see and what your advice to C-suite would be.
I think you're spot on in saying that unlike many other disciplines, even in software industry, machine learning is more an iterative process. That's why when companies say, hey, I'm going to formulate the big strategy, and then I will lay it out. It doesn't work that way, as you pointed out. You got to get into the habit of building ML models. And for that, I mean, you got to get your data in order, and then the right talent, and pick a few projects and start iterating. You're spot on in giving that advice to say, pick a few problems and so forth, which kind of leads me to one question. I'm kind of curious. Now, what do you think are the KPIs or key performance indicators to measure success of an ML project? Unlike many other disciplines in software, ML is a very iterative process where you actually start with it and the performance or accuracy of the models usually tend to be not so promising. And then you continue to learn and iterate. But many CIOs or even teams can prematurely give up, or they actually don't know how to measure, are they on the right track or not? So can you share some insights on what you have seen?
Yeah, I think, we're early phase of the development of AI as an engineering discipline. It took us a long time to figure out how to make software engineering a little bit more predictable. And I think we're in a much earlier phase of that journey for machine learning. So the KPIs and the metrics, they're very project specific. How do you have the multitude of engineering metrics that then hopefully relate to the business metrics, maybe additional metrics to audit for fairness and lack of bias. I think that the metrics are very project specific. But I do see there's one thing I often see on many projects, which is if you're working on a project for the first time in a completely novel application, it can be difficult to make up target metrics for AI team to succeed. And so I've seen C-suite go to AI teams and say, hey, I need to predict accuracy of diseases or ability to recommend products or inspect products in the factory or whatever. But can you guarantee me you'll be 99% accurate? And until a team has done either a proof of concept or if they're related projects in the literature, or the other companies have worked on, it's actually pretty difficult to establish some baseline level of performance that would be reasonable. If it's a project that the team has worked on, for example, I've built multiple speech recognition systems, so you ask me to build a speech system, I can kind of figure out how accurate I can make it because I've worked on it. But for brand new projects that, the team has not worked on, which is a lot of projects because AI is breaking new ground every day, I think that you just got to build that first prototype system, build it quick and dirty, build an initial just to get a sense of what might be possible.
I agree. I mean, that kind of speaks to my own personal experience too, that it's not like a standard high availability database where you measure availability in a certain manner or latency and so forth. This one is a lot more an iterative one, and it's going to be very specific to the problems you are solving and whatnot. Now, machine learning, what do you think is some of the major challenges? If you take a step back and say, hey, these are some of the major challenges that is actually stopping from ML going a lot more mainstream.
Yeah, I think there's a lot that needs to be done to make AI even more mainstream, but maybe just to pick one. A lot of AI projects, a lot of AI today has a proof of concept to a production gap problem, as you mentioned earlier.
Yeah.
And by proof of concept, I mean that lab demo. The data scientist or machine engineer gets something to work on the laptop, and then we go to and then say, wow, I achieved this really good accuracy on my test set. Or to take an example in the medical field, a lot of groups, including some teams I work with, have published research papers saying we can diagnose from X-rays, a level of accuracy comparable to human radiologists. Peer-reviewed results that will stand behind. Many groups have generated results like that. But it turns out that when you reach that milestone of the lab demo, there's still a lot of work needed to take that into production environments. There's all the software that needs to be written just to make that robust, manage the data, make it maintainable. We sometimes call the art and science of that ML ops or machine learning operations, which is a nascent and growing discipline. And then it turns out that just because when we, as I've done, take data, train it on data from Stanford Hospital, test it on data from Stanford Hospital, and we do really well there and publish the paper, it turns out when you take that same system and walk it down the street to an older hospital where, slightly older X-ray machines, slightly different imaging protocol, performance degrades rapidly. So how do you handle data drift and concept drifts? And so I think there are multifaceted problems like these, small data sets, that makes it difficult to take AI to some of the industries outside consumer software internet, where data sets are much smaller outside consumer internet. But I think we now see a path to solving these problems, but have to get through it.
You're essentially touching on three major things. One is having great data and then building an MLOps competency, and then third one is getting also new skills and training your developers to do that. Maybe let's dive into each of these. Now, how would you advise companies to get access to the right amount of training? I mean, data is the fuel for machine learning at the end of the day, and this is one area where we see many companies first finding a lot of starting difficulty.
Yeah. So two thoughts. One is I tend to advise most teams to jump in and just start doing something with a small data set. You can often go back, hopefully, to collect more data. But I've seen, actually, literally, at CEOs tell me, "Hey, Andrew, I spent this very, very large amount of money acquiring a company for their data. This has happened to me multiple times with multiple CEOs, and then now several years later, they're saying, "Well, Andrew, my board's looking to me to monetize this company I bought. Do you have any ideas?" And I kind of say, I wish I hadn't done that, right? Maybe. And then I tend to advise most teams to jump in with the data you have. And there's one other idea I'm excited about as a shift in terms of how we think about building AI systems, which is the way the AI had grown up in academia. We tend to take a very model-centric approach where we download the data set, iterate on the code or the neural network model, what have you, to make it work. But I find that for many practical applications, rather than a model-centric approach, where you hold the data fixed and try to improve the code, I find it's more useful to hold the code fixed and work on iteratively improving the data. And I feel like this is a nascent part of ML ops that I don't think anyone really has great tools for yet. But for many practical projects, I've gone to the machine learning engineering team and said, "Hey, everyone, please stop messing with the code. The UNet, RetinaNet, whatever model we're using is good enough. The only thing we're going to do is mess with the data so that when you train the code, you've already written on the data that there gets good performance." And sometimes giving that direction accelerates the team. And I think this whole field of data-centric AI development still needs to be fleshed out. So I'm excited about that as a major direction for AI.
That makes sense. I mean, our own experience with machine learning, and we see this with many customers, is data. Many scientists and engineers, they spend more time on data processing, annotation, and preparation than actually tuning the algorithms as much.
And you're right on, Swami. I feel like we even say it like it's a joke, right? Like we go, "Hey, did you know 80% of data science is actually data cleaning?" That's like a meme on the internet as well. And to me, I say, well, if 80% of our job is preparing the data, then I think preparing the data is a core part of our job. And I think having tools to accelerate, the efficiency with which we can do that will be critical to helping us build and deploy more machine learning systems.
I agree. While the number 80% might be more or less, depending on how nascent the field is, but you're absolutely right. There is a lot more. Especially, I mean, even in our own experience, even with techniques like active learning and so many others, we are starting to make the whole process of data labeling and annotation a lot better, and also learning with less data, various other things. We are starting to make progress, but we're still in early days. But now I want to switch to one thing you mentioned, the ML ops competency. So. And it's I don't think it is that widely popular for non-ML developers. So can you maybe share for a broader audience why machine learning ops or ML ops is so fundamental to this journey?
There's been a lot of excitement, rightly so, on people's ability to train an AI model in the lab and publish papers and generate good results. That's great. That's to be celebrated. And when I think of the full life cycle of a machine learning project, a lot more is needed than training a model. There is scoping out the project, deciding what to do, what not to do. There is collecting the data, which just talked about, is a key part of collecting enough data and ensuring high quality data. There's then training the model, and then there's also deploying it, monitoring it, see if the data changes, data-driven, concept-driven, flag that, flow the data back to the AI, push new models production, audit performance for any performance or fairness issues. So I think all of that workflow is a lot of work for which the tools to manage that process, I feel like are still, in the relatively nascent stage of being developed. But if we could build those tools, then we can empower a lot more people to build and deploy and maintain and effectively use machine learning systems.
Yeah, you're spot on. So one thing and it's a little bit like if I compare to software development analogy, there is so much focus on actually building efficient compilers for the code that we don't think about deployment and monitoring the production and seeing what bugs need to be fixed. So software development has gone all the way from writing the code to compiling and performance tuning and then deployment and monitoring. In ML development, as you're pointing out, MLOps competency is looking at the entire workflow and viewing it as a holistic manner instead of just focusing on training the model and so forth, but seeing end to end, which is how we look at it as well when we design tools like SageMaker, when we do the end to end.
I feel like DevOps is a really important discipline for building, scaling up, and maintaining software systems. And looking at, trying to contribute to the emerging discipline of ML ops, there's one very interesting thing. So AI systems is not just code, right? So for code, we had the DevOps discipline, but AI is code plus data.
Yeah.
And the interesting thing about data is that with ML ops, to manage the consistently high quality flow of data through the project, I found that ML ops needs to be more iterative, which you mentioned, Swami, than DevOps. Because with DevOps, you can implement it and then kind of throw it over the wall. Not really, right? Yeah. But you can kind of transition the code from a software engineering team to a DevOps team. Kind of, they need to work together, and then DevOps scales it up and maintains it. But ML ops, you cannot transition it. It's much less of a linear process because you're going to ship it. And then, the world changes, right? Build a speech system. People with a new type of accent start using a new microphone or new types of noise. And so the ML ops team, even more likely than the DevOps team, is to say, hey, the data changed, your system doesn't work. Here's some more data, and you should update your system. So it's been even more iterative in ML ops than DevOps. So that's been interesting.
I agree, especially the combinatorial explosion of data changes and code changes makes MLOps a lot more challenging and interesting than even DevOps on that front. Now, on the third one that you pointed out, which is around skills training for going ML mainstream, what do you recommend to a hiring manager or like an development manager or a CIO on what are the things they should be aware of to build a high quality data science teams? How do they go about finding these talent or training them?
Yeah, many companies hire or try to hire, and you can hire great data scientists, that's great. And the world today does not have enough machine learning engineers, enough data scientists. And so I see, frankly, more and more companies have good results, taking their domain experts, which already know their business really well, and give them a little bit of knowledge and training about how to use, data science tools and machine learning tools. Because to find interesting use cases in machine learning and data science, you need that interdisciplinary knowledge of the tech as well as the business application. And you can build an interdisciplinary team that works well. I often do that. That you can take people with the disciplined knowledge of your business, of someone's business, and give them a little bit of AI data science training. Then that single person can often come up with great ideas.
Now, you are among the most prominent leaders in education for ML, and you also co-founded Coursera as well. So, what is those experience in starting something like Coursera? Tell you about how we can actually make the education for ML easier and enable companies to train their talent more. So, how should companies think about ML training in general? Any specific courses? Because I'll give one example. I don't know if this aligns with your experience. In Amazon 6 years ago or so, we started our own machine learning university, where we actually said that we are going to actually introduce the basics of ML concepts all the way from ML 101 to NLP to computer vision to everything else. And we had SDEs and product managers, all of them take it along the way. And that has been wildly successful, which is one of the reasons why every business in Amazon is take on it. But nowadays, I don't think every company needs to start its own ML university because there is so much information available online. But what would you recommend on the ML training front?
Yeah, with the rise of online digital content, I think that it's easier than ever for a CEO or CLO or head of engineering to find content to level up the workforce in these critically needed skills. So I'm excited about the work that AWS and DeepLearning.ai has been doing as well to create content on data science. I hope that will help many learners. I'll just mention one thing that's often underappreciated, which is in addition to the technical skills, which hopefully they can learn from the various courses like the ones we're collaborating on. Yeah. It's also really important to get the executive level some non-technical AI knowledge because that actually makes it more successful, makes it easier for the executives to collaborate with the technical teams that will be responsible for these projects. So I think AI for everyone, right, is one example of a class taught by DeepLearning.ai often on Coursera that is targeted to help business leaders that may not themselves be software engineers learn enough about AI to manage this type of process. And with the rise of online digital content, I think it's easier than ever before for an executive leadership team, to find the right content that can very efficiently scale up a workforce. And I just mentioned one other really interesting trend, which is with so much content online, there's starting to be organizations as well, like Workera, which I'm involved in, that tries to help with precision upskilling by helping companies and learners figure out exactly what's the most useful thing for them to learn. So that's another interesting trend.
That's awesome. We are really excited about the collaboration with DeepLearning.ai and AWS in terms of bringing some state-of-the-art courses, I think. It will really enable us to train a huge number of developers as well. Now, one final question. I always wonder that if I were an engineer graduating out of high school or college today, for an aspiring machine learning builder who is learning some of these courses that you touched on and so forth, what are 2 or 3 advices you would recommend or gotchas along the way so that they can accelerate their progress in their learnings?
I find that the most skilled individuals in AI are often, kind of this T-shaped individual, right? That's something you hear about, but a broad base of technical knowledge together with a real depth in some areas. So I found that coursework tends to be a very efficient way for individuals to gain that broad base of technical knowledge because, instructors like the AWS instructors working with us spend a lot of time trying to figure out how to make it as efficient as possible for someone to pick up this body of material. So I find that important. And then beyond a certain point, to gain that deeper knowledge, you have to jump in and do project work. And I find that sometimes, hey, we all want to build a project that'll help, millions or tens of millions of people and create, massive economics while doing good for lots of people. And hopefully many people watching this will get there, or maybe are there already, I would guess, in the case of some people watching this. But if someone is just graduating out of high school and you don't have idea for doing that for your first project, perfectly okay. Yeah. Do a smaller project, get your hands dirty, and then use your small project to take the learnings to build the next bigger project, build the next bigger project. With the rise of relatively affordable cloud services, right? Thanks really to AWS and others, it's easier than ever before for people to train, develop, experiment with these sorts of systems. So I say, get your hands dirty, gain that knowledge from coursework, and then get your hands dirty. And then finally, I think community is important too. I think we're all shaped by the people around us. So if you're able to find like-minded people to share knowledge with and gain knowledge from, that often accelerates an individual's learning.
That's great advice. I really like the T-shaped individual analogy, and get your hands dirty and jump right in. Really interesting stuff. Just want to say thanks again for actually taking the time to talk to us. I mean, I'm really excited about the collaboration we are having from AWS and with deeplearning.ai as well. And really excited to bring machine learning and making it accessible to millions of developers who are really excited about making machine learning an integral part of what they are building. So I think we are in early days of machine learning revolution. And it reminds me so much of early days of cloud computing when I joined Amazon 15 years ago. And it still feels like there is so much invention to be done, especially for pioneers like you who are started in this space.
Thank you. Actually, let me tell one story, and then
Absolutely.
You know, a little bit before COVID, I attended an event in California called Maker Faire. And I saw this display by a student that had flown from India to the United States to display his robot. Where he built a little robot that used a camera to take pictures of plants and use machine learning to see if the plants were diseased. So I looked at this project and I thought, wow, if a Stanford PhD student had done the same project, 5-6 years ago, it would have perfectly fine strong chapter in someone's PhD thesis in Stanford Computer Science. So I asked the student, how old are you? And he said, oh, I'm 12 years old. So we now live in a world where the ability to do things that was kind of really cutting edge is available to a 12-year-old with access to computers, which I know not everyone has. But I feel like with online courses, I hope we can build a future where there are tons more people building all of these systems in every sort of imaginable industry. And together, I hope we can create a lot of value for everyone.
That is such an amazing and inspiring story, Andrew. So thanks for sharing. And I'll echo that. I'm really excited about what we are creating together. So for enabling students, and hope to continue the collaboration even more as well. Thanks again.
Thank you, Sonia.
Thank you.